Hello friends, welcome back. In the previous lecture, we have discussed about the Skempton's pore pressure parameters. In the present lecture, let us discuss about some of the minor topics. Let us start with the stress path. So, stress path is nothing but it is a representation of a plot by showing only maximum shear stresses and also stress representing at that point. Suppose let us say that let us keep your sigma 3 is equal to constant and let us change sigma 1. So if I am keeping sigma 3 constant, then I may get one more circle depending upon the sigma 1, and because of sigma 3 and sigma 1 I may get total shear stress at this point. If I keep constant sigma 3 and if I keep on increasing the major principal stress, then uh, the more circles will look like this. So if I'm not interested, or if I'm interested only in obtaining only the maximum shear stress value, or if I join only the points which are having the maximum shear stress, then if we draw another plot, means along the x-axis and along the y-axis. So where you will get the maximum, what is the maximum shear stress, that we can say it is a sigma 1 minus sigma 3 by 2. And where that will occur, that means what is the normal stress on the plane of maximum shear stress, what will be the normal stress, that is nothing but a sigma dash, that can be represented as sigma 1 plus sigma 3 by 2. That means along the x, let us represent with a magnitude p, a magnitude q. Suppose let us say that take a single more circle, right? Where you will obtain the maximum shear stress. What is the maximum shear stress value? The second set is sigma 3 minus sigma 3 by 2. And what will be the normal stress on the maximum shear stress plane? That is nothing but a sigma 1 plus sigma 3 by 2. Like that, if I keep sigma 3 constant and if I keep on changing the sigma 1 values, by more circles will also increase. But if I'm only interested in maximum shear stress and associated normal stress, then that is nothing but a stress path, or the stress path we can say it as a locus of points on the Mohr circle, whose represents whose coordinates represent the with the, what they will represent, they will represent the maximum shear stress and sigma dash. Sigma dash is nothing but a normal stress on the maximum shear stress plane. Then if we join all those points, then those are called it as a stress path. Okay, then how they will look like? Along the x-axis, what is the normal stress on the Tomax plane? That is nothing but a sigma 1 plus sigma 3 by 2. And what about along the y-axis? Along the y-axis, we will represent sigma 1 minus sigma 3 by 2. And if I join all those points, then that will be like some linear line. For one circle A, for another circle B, C, D, E, F, like that. Then if we join all those points, then this will be called it as a stress path. Now, let us talk about the liquefaction. So liquefaction, it is nothing but I can call it as a vibration effect. That means because of suppose wherever there is a possibility of earthquake zones, and in the earthquake zones, if there is a loose saturated sand because of the disturbance, then there is a decrease in volume of soil molecules comes closer, so such that your pore water pressure increases, then your effective stress will reduces drastically. So in that condition, as the reduce in the effective stress, or there might be a possibility that your zero effective stress will be there. That position is called it as a liquefaction of the soils. That means liquefaction, it is mostly occurs due to earthquake forces. It is mostly occurs due to earthquake forces which induce high pore water pressure. I can simply call it as a high pore pressure. That means, let us assume that there is a, and this is mostly applicable for the loose saturated sands. Imagine that there is a trench. In the trench, there is loose saturated sand. That means the soil particles are very distant from each other, and it is completely saturated. Suppose if there is an earthquake happened here, that means because of the vibration, what happened? Then the soil particles are comes close to each other. As they are comes close to each other, the volume will not change. But what is happening? If I keep my piezometer here, my pore water pressure is increasing. What is my effective stress? That is nothing but a total minus pore water pressure. Because of the disturbance, the soil particles will comes close to each other, and U value will be increases. As U value increases, your sigma value will be, effective stress will be decreases. If your effective stress as becomes zero, then that is what called the liquefaction. If your effective stress is equal to zero, then the soil will not resist any type of the stress, right? This is nothing but a liquefaction. Okay, now let us talk about the thixotropy. Thixotropy of clays. That means it is a phenomenon which represents the change in shear strength because of the remolding of the clays. That means what will happen? Suppose initially if you are taking any clays, they will be in the fluctuated shape. They will be a fluctuated structure. So if you are doing some disturbance, suppose if there is a disturbance, that means if you disturb the soil, or I can call it as a because of the remolding. If you are doing remolding, then what will happen? The fluctuated structure will becomes the dispersed structure. So as the structure changes to dispersed, then shear strength, your shear strength will decreases, right? Suppose let us assume along the x-axis I am representing with the time, and along the y-axis I am representing shear strength S. And initially the shear strength is S, but because of the remolding, the shear strength is suddenly decreased. But the soil is having such a property that as time is go on increasing, then the soil will comes to its original shape. So with respect to the time, the soil the soil will regain its shear strength. That means the process of increasing the shear strength of the clays with respect to the time, that process is called the thixotropy of the clays. And this is what about the, and also, and the sensitivity of the soils is can be represented by using the undisturbed strength to the remolded strength. That means, so let us, if I want to find out the sensitivity of the soil, then it is nothing but a ratio of shear strength, or I can say it as undisturbed strength, undisturbed strength to the original strength, or I can say it as a remolded strength. Suppose if your sensitivity is equal to 1, that means what does it implicates? Your undisturbed strength is equal to the remodeled strength. That means the clay is insensitive. Suppose if I say this is sensitivity is S. Suppose if S is equal to 1, what does it mean? Undisturbed is equal to remolded. That means after remolding the soil also, the strength is not increased. Then we can say that the soil is insensitive. That means the strength will not change even if you are remolding it. Suppose if your sensitivity, if it is coming greater than 16, then we will call it as a quick soil. Quick soil is also nothing but a type of soil. Okay. This is what about the sensitivity to represents the strength from the remolded to the undisturbed condition. Okay. From next video, we will solve some of the problems based on the theory, whatever we have discussed till now. Okay. Thank you.